Hi, this is Alan Gleeson for ADSR. Please subscribe to the ADSR YouTube channel for further tutorials. In this video we're going to be looking at expansion. Dynamics processing is part of every track used at all stages of a music production. Compression, limiting and gating are the most used and are familiar to most. In this video we will look at a process that often gets overlooked but is no less powerful: expansion. An expander, as the name suggests, is designed to expand the dynamic range of the material it is processing and has similar controls to those found on a compressor, with the main difference being what happens around the threshold. A compressor is designed to decrease the dynamics, and the threshold sets the level at which downward compression will be applied once the signal goes beyond that point. The reverse happens with expansion. Depending on whether the design is a downward or upward expander, when a signal goes below or above the threshold, the signal is attenuated even further or increased, thus increasing the dynamic range between the peaks and the lower level material within the signal. If all this sounds familiar, it's actually similar to how a gate reacts, and a gate is also a downward expander, except the expanders we're talking about have a softer approach due to the ratio control, and their task is to expand dynamics and not shut off the signal, though often a similar result is possible in both devices. So we'll start off by looking at the controls, and then we'll have a look at some examples. If you're familiar with using a compressor, the controls are pretty much the same. I've got this compressor inserted on a snare drum track. And this is the typical transfer curve of a compressor. This yellow dot here signifies the threshold point and what happens above that. As I increase the ratio, you can see that the signal above the threshold will be attenuated. So I'll put this back to a 2:1 ratio. In an expander, the opposite happens. So if I click this to expand, when the signal goes above the threshold, the level will be increased, therefore turning this compressor into an upward expander. So if I put it back to compressor mode and play it, we can see we're getting some gain reduction here. The signal has been attenuated. If I click into expand, you can now see the gain reduction is in the opposite way. So once the signal goes beyond the threshold, the level is increased. Let's bypass it. If I change over into the other view, you can see more clearly what's happening. So as the snare drum hits, the signal will be increased, and the rate of this increase and decrease to its previous level is controlled by our attack and release. So I can fade in the effect, which will reduce the response, or I can lengthen the release. Depending on the length of the source material, this will keep the whatever level is above the threshold here sustained at a higher volume, thus increasing the dynamic of this signal. Bypass it. So using an upward expander in that way, we can enhance or increase the dynamics of a signal and give the transient of the sound a bit more edge. So I'll switch over to another sound. We've got a bass sound here. So because this has a bit more sustain to it, we're using a similar setup here, using an upward expansion and adjusting our attack and release to add a bit more bite or a bit more attack to the transient. That's without the expansion. And you can hear with that when I bring it in, it has a bit more bite to it. So we can affect that shape with the attack and release. Obviously by adding more release, it will attempt to keep it louder for longer. We're bringing the release shorter release, it will respond quicker and have more snap at the beginning. So we'll switch over to one of our other sounds. So in this one, I'm using a different dynamics device. I'm using the multi-dynamics device in Ableton, and I'm only using a single band, which allows me to do both upward and downward expansion. So the previous two examples were upward expansion. This time we're going to look at downward expansion, which is the more typical use of expansion. And what happens in a downward expander is that once the signal goes below the threshold, the signal will be attenuated even further, thus increasing the dynamic range between the peaks and the lower level material. So I'll reset my ratio to 1, so there'll be no expansion being applied. And this is my threshold that I'm going to adjust here. So how this expander works is that the blue lines are the output signal, and there's a small yellow line or orange line at the top here, and that's my input signal. So as I adjust and add expansion, you can see the level change between these two. So I'll move my threshold to about there, and if I go below 0, I'll start to get expansion. So when I adjust my threshold, lower level material becomes attenuated. Bypass. Back in again. So you can see why this is similar to gating. It's not completely shutting off the signal, but it is attenuating it quite a bit. So put that in the context of the mix. Now deactivate it. Signal is more present there, it's more busy going on, where when I turn on the multiband dynamics, only the peaks remain. Reset my level meter there, see it's peaking at -13. When I deactivate it, still peaking at -13, the lower level material is back in, or it can have been removed. So I'm almost shutting off the lower level material there. So the other thing I could do on this other signal, if I felt that that signal wasn't dynamic enough, I can apply some downward expansion. So again, I'll bring up my threshold. The buzzing is from the attack and release, set too quickly. So I'm reducing the lower level material, it's still there, and I'm maintaining the peaks, thus expanding the dynamic range. So without the processing, most of the material is in or around the same level. It's a bit extreme, I'll reduce that. There's more of a range between the quieter and louder material. The other use of expansion is to actually uncompress a signal. Often when you've been sent material from another person, whether it's been mixed or mastered, some sounds can be overcompressed with their dynamics almost eliminated. Dynamics are what makes music interesting and gives us apparent loudness. So when all the dynamics are been removed, it actually has the opposite effect of decreasing loudness. So if I was to simulate this here by overcompressing this sound first. So I'll hard compress it. So there's not a lot of dynamic range in it there. So I'll bring in my multiband dynamics. So this time I'm going to do upward expansion. To go below 1. So you can see on the meters here that the orange is our original signal and the blue lines will be our output. I'm going to reduce my input a bit, so it's going to get louder. I'm going to tweak my attack and release times. So without it, the signal is at the same level most of the time, and when I add it back in, there's a bit more dynamic coming back into the sound. contrast between louder and softer parts. So it's not a miracle cure, but sometimes it can reintroduce a bit more dynamic into a flat sound. So that was a few examples of what expansion can bring to your mix. As mentioned, the tools we usually go for when trying to deal with dynamics are compression, limiting and gating, but expansion is another tool to be drawn upon to expand the dynamics, and variety in dynamics is what makes signals sound loud to our ears. So it should always be something considered when you're building a mix. This has been Alan Gleeson for ADSR. Please subscribe to the ADSR YouTube channel for further tutorials, and I'll talk to you again soon.